Kia ora koutou, ko Michaela tokoingoa. Hi everyone, my name is Michaela and I am a PhD student from Te Whare Wānanga o Tamaki Makaurau, the University of Auckland. And today I'm just going to talk to you about some of the work I've been doing for my PhD, which focuses on recently obtained drill core from the 3.48 billion year old Dresser Formation. But just quickly before I begin, I'd like to take this moment to acknowledge the Ngunnawal people as the traditional custodians of the land in which my fieldwork took place, and also extend any respect to all First Nations people present. So, a quick background of the Dresser Formation for those who might not know. It's a geologic unit that's 3.48 billion years old and is located in the Pilbara Craton in northwestern Australia. The paleo-environmental setting for the deposit is an ancient dynamic hydrothermal volcanic caldera setting, and this caldera setting would have undertaken periods of inflation and deflation, as well as having a lot of hydrothermal fluids circulating around. But what's really interesting about the Dresser Formation is that it provides Earth's most convincing evidence of early life in the geologic record. And this is through a diverse array of biosignatures. And one of these biosignatures are stromatolites. So for stromatolites, for those who might not know, are interlayered microbial and sedimentary structures. And these just build up over time on top of each other. And so the top picture, we have an example of a modern analog, so one that's currently alive. And this is in Shark Bay, which is also in Western Australia. Maybe not the prettiest form of life, but it has survived for more than 3.5 billion years. And then on the bottom image, you can see an outcrop image of a stromatolite from the Dresser Formation. So if you look at where those white squiggly lines are, those are the microbial mats. So essentially what you're looking at there is your great, great, great times a million grandparent. So can you guys see the wrinkles? So the stromatolites in the Dresser Formation are found in a range of different paleo-environmental settings. This is ranging from shallow lagoon all the way to hot spring deposits. So this is work done by Dr. Tara Jokic for her PhD. And what she did is she actually went out and she mapped a bunch of these stromatolites and discovered hot spring stromatolites. And this is an example. So if you look at the boxes D, B, and C, you can see the microstromatolites in this. And what's really exciting about this discovery is that this is the earliest evidence of life on land. So this is an amazing discovery that Tara did for her PhD. I'm just going to take a step back now and explain why hot springs are so important when it comes to looking for life in extreme environments, and how this can relate to origin of life studies and early life, as well as possible life on other planets. So for those who might not know how hot springs form, so what happens is you get meteoric water, so rainwater, and this percolates down through porous cracks and fissures in the underlying rock. And as it percolates down, it eventually comes close to an underlying magmatic source. And this magmatic source gives off a bunch of heat, which causes convection, and therefore the hot water begins to rise. And as it rises, it actually leaches minerals from the surrounding rock. And this is a wide range of minerals. And so if you imagine you had a cup of boiling hot water, and you added a teaspoon of salt into that and you stirred it around, that salt is going to dissolve. But if you let that hot water cool down, eventually that salt will reprecipitate out of the hot water. And it's a similar component when you look at hot springs. The hot water is leaching all of these minerals from the surrounding rock, but eventually it will outflow. And here we have a picture of some PhD students in Yellowstone taking some very important notes on geysering and geyser formation. But yes, the hot water will outflow and eventually it will cool down. And so what you get is these vast plains of hot spring deposits which are undertaking a bunch of different temperatures. They have a bunch of different pHs and they have a bunch of different water chemistry based on the minerals that were leached, the distance from where they outflowed from the vent, and the different types of interactions with the chemistries. And so if you look at these stunning pictures from Yellowstone, everywhere you see those vibrant pink, orange, yellow, green, brown colors, those are all microbial mats. So what's super important about hot spring deposits is that life is everywhere in these systems. Life is thriving in all different temperatures, all different pHs, and all different water chemistries. So these are extreme environments that are teeming with life. And what is also really interesting about these pictures is everywhere you see that white kind of gray color, that's actually a mineral called silica. And so as I said before, the minerals get incorporated into the hot water because they dissolve. But eventually, as this hot water cools down and eventually dries out, minerals reprecipitate out. And one of these minerals is silica. And so what's really important about silica is that it rapidly entombs these microbial mats. So what you're looking at right there is active fossilization. So you are essentially looking at rock being formed. And this is what's happening with the early life studies. We have rapid entombment of these microbes. And so we have been able to go through and we've been able to map the type of hot spring facies, so the type of deposits and textures you'd expect to see based on distance from the vent, from where the hot water comes out. And this gives you an indication of where you are in the system based on distance from the vent and temperature. And this is what Tara did for her PhD. She went out and she mapped a bunch of these different hot spring deposits in the dresser, including this one, which I showed before, which is actually geyserite. So that's right at that vent. So these would have been extreme thermophilic, so heat-loving microbes. It was an absolutely stunning PhD and amazing work from Tara. The only issue with these deposits is that they're from outcrops. And these outcrops are weathered to 70 meters depth. So because of this, a drilling project was proposed based off the work that Tara did to try and intersect these hot springs at depth. And this is what my PhD focuses on. So here are some stunning images of us out collecting our drill core in the nice and toasty 40 degrees Celsius outback heat. You can see us also trying to fight away the flies while we were eating. And so we obtained 4 drill cores of 5 to 30 meters in length. And what we found is that these drill cores show excellent preservation of biosignatures, of textural biosignatures. So here is an outcrop image of stromatolites. And if you follow my mouse, you can see where the stromatolites are. And so there's been a lot of discussion in the scientific literature over the authentication of these biosignatures. But if you look at the core deposits, you can actually see how well preserved these textural biosignatures are. These are absolutely stunning preservation of stromatolites. And not only that, but we actually have potential primary minerals of pyrite being preserved as well. So we're very excited about the preservation in this core, and particularly this horizon is of interest because you can see the stromatolites have been preserved because of an event horizon. So there was some carbonate sandstone on top. And so we thought it would be interesting to image into the core to see the 3D morphology of these deposits. So we went over to ANSTO, which is over in Australia, and we used the dingo, and Australians love giving animal names to high-powered machines. And this imaged through the core, and if you look at this middle horizon, you can see the stromatolites popping in and out. And this actually helps us with this biogenicity because it shows that these stromatolites are 3D in morphology. So that's very exciting, and it's something I'm working on at the moment. Another interesting discovery that we've made in the core is that if you look at the core or correlate the cores between each other, you find that there's not a lot of areas where correlation can occur. However, when you take a step back and you try and correlate with outcrops that are kilometers away, we start to see repetitions of specific horizons. And one of these horizons is this green swirly horizon you can see in these stratigraphy logs. And here's a picture of the green swirly horizon outcrop and then in core. And when we start to think of environments that show this similar repetition, geothermal systems are one of these, where you don't have a lot of correlation in the small scale, but when you take a regional scale, there is a lot of reoccurring lithologies. So we're actually quite excited because we think this could potentially be some more hot spring deposits. We also think we've discovered some Palisade texture. So Palisade texture forms on the distal apron of a hot spring. And what's really interesting is that if this is Palisade texture, then this would be the earliest evidence of microbial filaments in the geologic record. So that's what I'm currently investigating at the moment as well. And then finally, we've identified several horizons with spheral deposits. And these spheral deposits have textures that are similar to impact spherals. So the early Archean would have been a really hostile place to live. There would have been no atmosphere, and what is also predicted is that there would have been constant bombardment from these large impactors, the scale that would have killed the dinosaurs. But unfortunately, the geologic record is quite sparse with indications of this. So this is really exciting because this helps try and fill that gap. But also, if these are impact spherals, then they would also be the oldest in the geologic record, which is quite exciting. So that's just a quick brief results of what I've been finding in my course. And I just want to say a big thank you for listening and big thank you to our sponsors. And also here is what people in the Outback consider to be puppies for those who are interested. Thank you. Ka kite anō.